This is the food truck project by the High Voltage Team number 13. My name is Gabby, and I will be presenting with my teammates Madison and Rick. Our problem statement is, it can be tricky to maneuver food across a large dinner table while hosting gatherings. We are developing a system to make it easier for people to do so. We decided this was a good problem to focus on because we've all encountered difficulties when passing food around during large gatherings. Our concerned people include target customers and end users, who are mainly individuals who host large gatherings, such as large families or catering and banquet services. Other concerned people include investors, who will be providing funding needed to develop our designs further. The person that I interviewed was my neighbor, Allison, who frequently hosts dinner parties. Two responses from Allison that we considered were the price that she was willing to pay and the comment she made on the size of the design.
For the interview, I chose to talk to Richard Bolton, who is a military Air Force officer in my local community. He said, from his perspective, it should serve more than for 4 people. The food truck should cost between $70 and $200. Should be visually appealing. Prefers it to be lightweight and compact, nothing bulky, and he prefers nothing to be required to be assembled. It should come already put together. And he said that it should not be for military gatherings.
The customer I interviewed is Kathy Mills, a housewife, age 58. Main points are she wanted something small in size that does not take up much storage space, preferably low in price, approximately $50. She typically hosts 6 to 12 guests multiple times a year. She uses multiple tables for serving, and she had concerns of the device being too complicated.
In addition to the project requirements that we were given in class, additional design requirements that we came up with were that the design shall make it easier for food to be shared in large groups. The total cost to produce the design shall be less than $100, and the design shall be small in size, or less than 2 feet tall and less than 10 pounds, so that it would be able to fit on top of a table.
The CAD models were created with Autodesk Fusion 360. On the left is the front view of the assembly. On the right is the side view of the assembly. On the left is the bottom view of the assembly. On the right is an isometric view of the assembly.
Design functions mechanically include the sub-level, which is the level in which input is given and creates the wheels to rotate when activated. Output. The middle level, this is the power level, which would be the input. Top level would be the power from the input level, which rotates the serving dish, which would be output. Electrical functions include sub-level contains 4 DC motors connected to a track board. When activated, it rotates the wheels of the cart. The middle level contains an Arduino board, L298N board, Bluetooth sensor, ultrasonic sensor, and 2 battery packs, which is considered the power level. Top level contains 1 DC motor attached to the serving dish to rotate when activated.
The food truck is unique because it has multiple ways of operating. The customer has the option of operating the food truck by remote control, line tracking, and running an automated program.
For the following 2 slides, this is going to be the code. The code can be adjusted due to the fact that the robotic kit that we got off of Amazon, it can be adjusted to modify the speed, direction, and avoid different obstacles. And you can adjust it as how you see fit. And how we had it set up is it just goes different speeds and just goes a typical back and forth motion.
Our initial design was a stationary 3-tier model that had a rotational plate on each tier of the model and would sit in the center of a table. We decided that it would be better for the model to be able to move around to different guests at the table. And so our final design has only one rotational plate that is mounted on top of a moving base.
For the budget, our most expensive item was $70, and as you can see, the rest of the remaining items were not that much. But the reason why the top robotics kit was so much is because it had so much material in it, and that was basically our computer and electrical parts. But it came to a total of $87 approximately. That's not including like taxes or anything like that.
The easiest way to explain our work division throughout the duration of the project is to refer to the Gantt chart that we produced as a team. We were all heavily involved in the research process during the first couple weeks of our project. Each of us watched all the lectures and conducted an interview with a potential customer, which led us to the preparation stage of our project, where we each developed a new design concept based on the responses we got from our interviews. And then we discussed those concepts as a team and chose one of them based off of different criteria. And then once we had a design in mind, we figured out which parts to buy and purchase those parts. When developing the CAD files, we each designed at least one part. However, Rick designed most of the parts as well as put them all together in one assembly. Madison was the most active during the prototype portion of our project, and she built the physical model as well as did the programming and testing. During the revision stage, she kept us engaged with the project by sending us videos as well as taking suggestions. One similar concept to our design is the conveyor belt system found most frequently in sushi restaurants, where food travels around on a conveyor belt until someone decides to pick it up. The difference between that system and our design is that our design accomplishes the same task on a much smaller scale, and makes it a lot more suitable for our target users who will mainly be using the product in their own home. So to sum up our presentation, we are hoping to add value by developing a design that allows food to be maneuvered around a dinner table during large gatherings with family or friends. And the problem that we are hoping to diminish or eliminate is the distraction caused by passing plates around, or knocking food and drinks over. And we have come up with a unique design that we are hoping will overcome this problem. And we have developed a prototype which we will present in the upcoming slides.
We have learned that your first design choice isn't always the design in the end. We had a teammate drop the class after we decided to go with her design. Since we could no longer communicate with her about her design idea and intentions, we decided to combine some features of her design with another design. It is important to be willing to adapt or change plans as problems arise.
Hi everyone, this is our design that we assembled and created as the high voltage team, and the name we actually gave this is the food truck. Kind of ironic because it looks like a food truck and it's going to go serving people on a table. So what we had to do was basically create a 3-tiered model with a serving dish on top that also rotates. Our 3 motions is the serving dish, and the forward-backwards motion, and also does an added 360 spin, side to side, does different motions on the cart itself. Like I showed in the last video, on the bottom layer we have the motors with a couple of other attached sensors. That's the tracking sensor on the bottom. On the second level, as you see here, we have the Arduino board and the L298 board attached to the battery packs, and the ultrasonic sensor is attached to that, which is here in the front. We kind of turned it into little mini headlight looking things to make it look cute. The burlap ribbon is just kind of an added design effect. This 3-tier model actually did not come with a kit that was used to create the cart portion. Like I explained in the last video, this cart was actually bought off of Amazon as a assembly kit. So it started off as 2 boards, and we had to assemble the entire robot. But this board, the 3rd level, was actually made out of paneling, along with spacers, and this was also hand painted. And underneath here we have another motor with it attached to its own separate battery pack, and I'm going to show you how it works. So you're going to turn here and you're going to turn on the devices. Once you turn this battery pack on, that's when your top serving dish is going to start spinning, as you can see there, and the cart can go forward, it can come backwards, and it can also do side spins like that. But everything is controlled by the cart with this remote, but the top layer itself will just spin on its own. It is not powered by the remote since it was an added on motor. But that is our project. Thank you, everybody.